Hi students, in this video we are going to work out problems from exercise 8.1, which is from chapter 8, applications of integration. Okay, the first question is find the area of the region bounded by the curve y square is equal to x and the lines x is equal to 1, x is equal to 4 and the x-axis. So you are going to find the region bounded by the curve y square is equal to x and the lines x is equal to 1, x is equal to 4 and the x-axis. So first let us draw the curve and the lines and let us find out the region that is bounded by these given curves and lines and the x-axis. So first let us draw it. Let us draw x-axis, the y-axis, and y is equal to x is the curve. You have already learned uh, parabola, ellipse, circle, all those things. So you look into this equation, it is the equation of a parabola. And y square is equal to x is the parabola that is symmetric about x-axis and open right. So you have to draw the parabola. You can substitute the points for when x is equal to this, y is this, x is equal to this, y is this. But we are not in need of an exact measurement picture. Just you can draw it. Okay. So um, the parabola is open rightward. This is the parabola y is equal to x. So when you put when x is 0, y is also 0, right? So it starts from the vertex. And now listen, this is the parabola, this is the curve y square is equal to x. And now you're supposed to draw x equal to 1, x equal to 4 and consider the x-axis. Now let's draw x is equal to 1. So x is equal to 1 is a line that passes through the point 1 to x. Okay, that is point 1. X is equal to 1 and now let's draw the line x is equal to 4, which is okay, x is equal to 4. So this is x is equal to 1 and this is x is equal to 4. And now let us check it. Okay, now look into the figure. Now you have to find the area of the region bounded by the curve y is equal to x square. So this is the curve y is equal to x square and x is equal to 1 is this line and x is equal to 4 is this line and the x-axis is this line. So the required area is you have to find this shaded region, area of this region. And you check out the limit varies from 1 to 4. Okay, so x is equal to 1 to x is equal to 4 is the limit. So you have to find y. So you have the equation y square is equal to x. So what is y from that? Y is equal to square root of x. Now let us move with the formula so that we can find the area of the required region, the shaded region. Okay, so now it is okay. So whenever this kind of questions are given, first you draw the figure very carefully and note down the limits of x. Here x is equal to 1 and x is equal to 2. This is the limits, and when you get the limits in x, you are finding y from the given equation. The next step is find y from the given equation. It will be a function as in x, so that you can substitute the value of x in the formula. So now you are supposed to find the shaded region, area of the shaded region. So you can say required area is equal to required area is equal to integral 1 to 4 y dx. So when you get the limits in x, you take the equation y is equal to, and that is a function in x, and you integrate it with respect to x. This is the formula to find area of the required pair. That is an integral f of x dx, right? And now you just substitute the value of y from there. So it is 1 to 4. What's the value of y? X square root of x and dx. X upon it is x power 1 by 2. What's the integration of x power 1 by 2? It's x power 1 by 2 plus 1 by 1 by 2 plus 1. So it is x power 3 by 2. So it is x power 3 by 2 by 3 by 2. And the limit varies from 1 to 4. And now you can take the constant outside, like 3 by 2. When you're bringing it to the numerator, it becomes 2 by 3. And x power 3 by 2, the limit is from 1 to 4. So now we can substitute the limit, upper limit minus the lower limit. So we substitute 4 in place of x first. So it is 4 power 3 by 2. Minus, you substitute the lower limit, it is 1 power 3 by 2. So it is equal to 2 by 3 into 4 power 3 by 2 is 8, and 1 power any number is 1. How do you get 4 power 3 to be 8? 4 power 3 to 4 power 3 by 2 is 4 power 1 by 2 the whole cube. 4 power 1 by 2 into 3 is 4 power 3 by 2. And that will be equal to square root of 4 is 2, so it is 2 power 3, so it is 8. So now you simplify it, you'll get 14 by 3. 14 by 3, and because it is area, the unit is square units. Okay, square units. That's all. So every time you get a question of this kind, that is in application of integral, all you have to do is you read the question, understand what kind of curve is given. Is it a parabola or ellipse or a circle? And draw the graph very carefully and taking into consideration all the lines, limits, axes given. You mark the shaded region very carefully, note down the limits and find the equation. If the limits are in x, you find y. If the limits you are taking in x, you find x from the given equation. And then move with the formula, substitute it, simplify it, and that's it. So let's move to the next question, which is question number 2. Question number 2. Let me clear the screen. We can take next page. Yeah. So question number 2 is okay. Let's read the question number 2. It is find the area of the region bounded by y square is equal to 9x, x equal to 2, x equal to 4, and the x-axis in the first quadrant. So all you have to do is read, understand all these curves, okay? Y is equal to 9x, x is equal to 2, x is equal to 4, and the x-axis. So the region bounded by all these four is the region for which you have to find the area. Okay, so first draw the diagram very carefully. Now to draw the curve y square is equal to 9x, you know to draw the graph of any given equation, right? So by substituting x equal to 0, you get y equal to 0, so it's the origin point, and x equal to 1, you will get value for y. When x is equal to 2, you will get the value for y. You can plot the graph and get the exact graph, but we are not in need of an exact graph. We can just do it by looking into it. You can guess that it is a parabola, because what's the equation of general form of the y square is equal to 4ax, right? Or x square is equal to 4ay, or even the sign you have minus 4a, something like that. Okay, so you know how to find out the curve is a parabola, and you know how to check out whether it is open right or left or up or down or symmetric about x-axis, y-axis. All these you have learned in grade 11, and you have to directly just draw it. That's all. And so you draw the graph, x-axis and y-axis, and then proceed with marking it all. So it is okay. So what is x-axis here? X, the x dash, y, and y dash. And now you draw the parabola. So here the parabola is y square equal to 9x. So it is symmetric about x-axis and open rightward. Okay. So it is symmetric about x-axis and open rightward. You can just draw a graph. Okay. It necessarily need not be of exact measurements. And the origin, it passes through the origin, and the curve is like, it should be symmetric. Okay, so draw it very carefully and very neatly than what I have done here, or I can follow a method like. Mhm. Okay, draw the parabola very carefully. And this is the parabola y square is equal to 9x. Plot the Now draw the line x is equal to 2 and x is equal to 4. And so x is equal to 2 and x is equal to 4. Okay, x is equal to 2 and x is equal to 4. So you can now guess out the area that is to be area of the region that is to be found. So it is the curve y is equal to 9x in the first quadrant. 9 is equal y square is equal to 9x and x is equal to 2, that is this line, and x is equal to 4, this line, and the x-axis. So x equal to 2, x equal to 4, the x-axis, and the curve. So this is the region to be bounded. You shade the region very carefully. This is the region to be considered. So this is the required region for which you are supposed to find the area. Okay. So you know what's the limits. The limits are like x is equal to 2 to x is equal to 4, right? And the given equation is y square is equal to 9x. So you have to find y because y is equal to square root of root, okay, the 3 root x. So now let us move on with the finding the area. Okay, let's move on with finding the area. So required area is equal to required area is equal to integral 2 to 4 and it is y dx. So what did you get as y? So that is equal to integral 2 to 4 and y is 3 root x into dx. So you can keep the 3 outside so it becomes 3 into integral 2 root 4 root x dx. And what's the integration of root x? It is integration of x power 1 by 2, right? So it is x power 1 by 2 plus 1 by 1 by 2 plus 1. So it is x power 3 by 2 by 3 by 2. So that's equal to 3 into x power 3 by 2 by 3 by 2 and it limit varies from 2 to 4 and that is equal to 3 into you bring the 3 by 2 outside it becomes 2 by 3 and it is x power 3 by 2 2 to 4 and 3 and 3 gets cancelled you get 2 times substitute the limits, okay? So upper limit when you substitute x is equal to 4, it becomes 4 power 3 by 2 and it is minus the lower limit when you substitute it is 2 power 3 by 2 and the final answer is 2 into 8 minus 2 root 2 that's equal to 16 minus 4 root 2 square units. That's all. So how do you get 4 power 3 by 2 as 8? The previous problem we did it, right? So how do you get 2 power 3 by 2, 3 power, um, how do you get, um, how do you get 2 power 3 by 2 as that? It is 2 power 1 by 2 the whole cube, right? So it is square root of 2 the whole cube. So it is root 2 into root 2 into root 2. So it is 2 root 2. Okay, that's it. And now multiply 2 inside, you'll get the final answer. Now let's move to the next question, which is question number 3. And you will find all these problems very easy. Like all you have to do is draw the graph very carefully. So it is a parabola, it's a parabola, and sometimes a circle and sometimes an ellipse and you draw the picture carefully, draw all the values given like x is equal to 2, x is equal to 4 and consider all the boundaries and mark the shaded region, find the limit, find the equation, put it in the formula to find the area and then proceed, simplify it, that's all. So let's move on with the next question, which is question number 3. Okay, read the question very carefully and find out the region to be A region bounded by the given curves for which the area is to be found. Okay, let me read the question. Find the area of the region bounded by x cube, never, which is x square. Oh, sorry. X square is equal to 4y. Okay, x square is equal to 4y. Now listen, actually the first four problems are almost the same. And the first two you listen, right? Now the third one and the fourth one, you try it by yourself and then come back to the video to check out it. Okay, if you have any doubt, you can just refer to it. Better do it by yourself and then come back to the video to check your answer. So now let us find out the required region. Okay, let us find out the region that's bounded by x square equal to 4y, y equal to 2, y equal to 4, and the y-axis. So this is what we are going to find now. That is okay. Let us draw the graph. So it is the parabola x square equal to 4y, right? It is the parabola x square is equal to 4y. So it is symmetric about y-axis. The parabola is symmetric about y-axis and open upward. There's no minus sign, so it is open upward. So let us draw the graph first. Okay, okay. Okay, the parabola is open upward because it is x square is equal to Okay, here's the rough sketch of the parabola y. X square is equal to 4y, which is symmetric about y-axis and open upward. Okay, and now let us plot the line y is equal to 2. Draw the line y is equal to 2 and y is equal to 4. So y is equal to 2. Plot the point. You draw the line from the point 2 just parallel to x-axis. That is the line y is equal to 2. And now draw the line y is equal to 4. Starting from 4 parallel to the line x-axis, you get it. So that is the line y is equal to 4. So what is the region bounded? Actually, it is in the first quadrant, right? First quadrant. And y is equal, it is the region bounded by the parabola y square, sorry, x square. Okay, x square is equal to 4y. It is the region bounded by x square equal to 4y. The line y is equal to 2 and the line y is equal to 4 and the y-axis and the y-axis. X equal to 4, y is equal to. So this curve, this line and the y-axis. And it's in the first quadrant. So what's the area? The area we got is this much. Now you are supposed to find the area of the shaded region. So let us move on with that. Secured area is equal to integral. You have to find the limit first. So it is y is equal to y is equal to 2 to y is equal to 4, right? Y is equal to 2 to y is equal to 4. And now you find what is x. So x squared is equal to 4y is the curve, and x is equal to square root of 4y, it is 2 root y. So the limit varies from 2 to 4, and it is x dy. And now that is equal to integral 2 to 4, and what is x? It is 2 root y into dy. Now integrate root y with respect to y. So integration of root y dy is equal to y power 1 by 2 dy, right? So it is y power 1 by 2 plus 1 by 1 by 2 plus 1, and that's equal to y power 3 by 2 by 3 by 2. So it is y power 3 by 2 by 3 by 2, and the limit is from 2 to 4. That is equal to 2 into, take the 3 by 2 in the denominator outside, so you get it as 2 by 3. Y power 3 by 2, 2 to 4. Just substitute, find answer. 4 by 3. Substitute the upper limits, so it is 4 power 3 by 2 minus 2 power, lower limit is 2, 2 power 3 by 2, and simplify it, you get 32. Multiply this 4 by 3 inside then, okay? So the final answer is 32 minus 8 root 2 by 3 square units. So the next one is also of the same type, like parabolic curve is given and the limit change. So you can try it by yourself. Try quiz number 4 by yourself, and then you come to the video to check it out. Okay, actually the fourth question is not same as the first three. It is different. Find the area of the region bounded by the ellipse x square by 16 plus y square by 9 is equal to 1. Here just the ellipse is given, right? The ellipse is given and you have to find the region bounded by this ellipse. Okay, so actually you look into the ellipse, it is symmetric about x-axis. How do you find that? You compare it with x squared by a square plus y squared by b square. That's the general form, right? So if here a square is 16, so a is equal to 4 and b is equal to 3, right? So a is greater than b. So the major axis is along x-axis. So you have to draw the ellipse this way, and what else? Okay, so these endpoints, this is 0 comma, this is minus a comma 0, so it is minus 4 comma 0, and this point, this vertex is 4 comma 0, a comma 0, so it is 4 comma 0, and what about this 0 comma b and 0 comma, this is also distance 3, so it is actually minus 3. So after drawing the graph, you just find out which areas to be found. The whole region inside this ellipse is to be found. In area of the whole region inside this is found. But it is enough to find the area of, but it is enough to find the area of the closed region in the first quadrant, and you have to take 4 times of that. That's all. So you have to, this is the required region, and 4 times of that will give the area of the required bounded region. And here the limit varies from 0 to 4. If you are taking it in, if you are taking x is equal, you can take x is equal to 0 to x is equal to 4, or y is equal to 0 to y is equal to 3. Okay, if you are taking x limit of x equal to 0 to 4, then you have to find y from the given equation. So what's the given equation? X squared by 16 plus y squared by 9 is equal to 1. You are supposed to find y from this. Suppose you take the limit of 0 to 3, x is equal to y is equal to 0 to y is equal to 3. Then you are supposed to take the, find the x values from x. Now let's find y because we are taking the limit of x equal to 0 to x is equal to 4. Okay? And you get it as y squared by 9 is equal to 1 minus x squared by 16. So take the 9 there, y squared is equal to 9 into 16 minus x squared by 16, 9 by 16. So taking square root on both sides, it is 3 by 4 into square root of 16 minus x squared. Okay, so now let's move on with the steps. These are very important steps. Okay, so getting the equation of y is a very important step. Do it very carefully. Okay. And now you can just start with the answer like x squared by 16 plus y squared by 9 is equal to 1 implies y is equal to 3 by 4 into square root of 16 minus x squared, and the limit varies from x is equal to 0 to x is equal to 4. The curve is symmetrical about both the axes. Therefore, you can take the area of the bounded region is therefore area of the bounded region is equal to 4 times integral y dx. So the limit varies from 0 to 4, and that is equal to 4 times the 3 by 4 you can keep outside. 3 by 4 into 3 by 4 you can keep outside. The rest you put it inside like 16 minus x square dx. That is equal to. Now you look into the formula which we learned in the class, which is yeah, just recall these two formulas which you learned in the class. Like square root of x square plus a square is equal to 1 x by 2 square root of x square plus a square plus a square by 2 log mod x plus square root of x square plus a square plus c. Another one is square root of a square minus x square dx is equal to x by 2 square root of a square minus x square plus a square by 2 sine inverse x by a plus a. So now we have got the equation of the form this, right? It is 16 square minus x square. So you are supposed to substitute, use this formula and find out the final answer. Find out the final answer. So yeah, just look into it and substitute the same formula. We will get substituting the formula. We get so outside 4 and 4 get cancelled. You have only 3 outside, and substituting the formula you get x by 2 square root of 16 minus x square plus 16 by 2 a by 2 sine inverse x by and it limit is from 0 to 4. Limit is from 0 to 4. Now you substitute the upper limits minus substitute the lower limits. You get the simplify it, you get the answer. Okay, so it is 3 into substitute 4 now. Okay. Actually, you can just put it in mind and make this step smaller, like you know. When you substitute 4, this term becomes 4 4s are 16. So it is 16 minus 16 0. So x by 2 into 0 is 0. So when you substitute 4 in the first term, the first term becomes 0. You can directly write it as 0. And then you substitute 4 in the second term. What do you get there? Yeah, you get something. So it is plus 16 by 2 is 8. You can just directly write 8. Sine inverse 4 by 4 is 1. So you can write it as sine inverse 1. And now this is upper limits. Okay, now we are supposed to substitute the lower limits. So it is minus, you substitute the lower limits, it is 0, right? So when you are substituting 0, 0 by 2 becomes 0, 0 into this becomes 0. So the first term is 0 again. And coming to the second term, substitute 0, it is 8 by 8, it is 8 into sine inverse of 0, which is 0. So actually it is 0. So you can directly write 0 there. No need to go on with so many steps. 0 when you are substituting, sine inverse of 0 by 4 is sine inverse of 0. Sine inverse of 0 is 0, so you get it as 0. Okay, so finish it up. That is equal to 3 into 8 sine inverse 1. What is sine inverse 1? It is 90. 8 3s are 24, and sine inverse 1 is pi by 2. So it is 12 pi. And because it is area, it is square units. That's all. So the next problem is similar to it. Okay, so whenever you get an ellipse, you find A and B from that by comparing it with this. A is 4 and B is 3. If A is greater than B, if A is greater than B, then the axis, the ellipse is symmetric about x-axis. If A is less than B, then the ellipse is symmetric along y-axis. Draw the plot the figures, you get the limits, and then you find the equation, substitute there in the formula, and you have an extra formula to apply here. You learn that formula thoroughly. That's in page number. That's in page number. Okay, you have to check out. Okay. So let's move to the next question, which is question number 5. Find the area of the region bounded by the ellipse. X squared by 4 plus x squared by 4 plus y squared by 9 is equal to 1. So here, you looking into the equation, you can immediately say that the ellipse is symmetric about y-axis, because here A is 2 and B is 3. Right? A is less than B, so the ellipse is symmetric about y-axis. So let's draw the graph. Let us draw the graph first. And the thing is, in parabola also, you can find, you are finding it very easily, because you have to keep in mind all the four formats, like x square is equal to 4ay, x square is equal to minus 4ay, y square is equal to 4ax, and y square is equal to minus 4ax, right? So when you have minus, it is open left or open down. When it is okay, when it is okay, When it is x square is equal to 4ay, it is open. It is symmetric about y-axis. And when y square is equal to this, it is symmetric about x-axis, right? Symmetric about x-axis. When you have a minus, it is to the left, open left. And when you have minus here, it is open down. Okay, open up or down when it is symmetric about y-axis. When it is symmetric about the x-axis, it is open left or right. You have a minus, it is open left. And when it is x square equal to 4a, it's symmetric about y-axis. And it will be open left, up or down. When you have a minus, it is open down. So draw the picture very carefully. And here you should take care of the whether it is symmetric about x-axis or whether the ellipse is symmetric about x-axis or y-axis by looking into the values of a and b. So first you find out a and b and then proceed with that all. So it is x dash and y dash, and here the ellipse is symmetric about y-axis. So let's draw it. The ellipse is symmetric about y-axis because b is greater than a. Here you have a is equal to 4, a square is 4, so a is 2. And b square is 9, so b is 3. And here a is less than b, so the major axis is along y-axis. And so the ellipse is symmetric about y-axis. Okay. Now 0 comma a comma 0, that is 2 comma 0, and minus a comma 0, that is minus 2 comma 0. And what about the major axis? It is 3, right? So it is 3 comma 0 comma 3 and minus 0 comma minus 3, 0 comma minus 3. Okay, plot the points carefully, and now you have to find which is the region, which is the required region. Region bounded by the ellipse. So the whole region area for the whole bounded region you have to find. 1, 2, 3, 4, the whole thing inside the ellipse. Okay, it is enough to find the area of the first quadrant and multiply 4 times. So let us find the area of the region bounded by the ellipse in the first quadrant, which is this is this part. And okay, so here the limit varies from 0 to 2. Okay, so x is equal to 0 to x is equal to 2. So the limit varies from x is equal to 0 to x is equal to 2, and now you have to find y from the given equation. What's the given equation? The given curve is x squared by 4 plus y squared by 9. All these steps you can write in the fire, okay? Y squared by 9 is equal to 1. So to find y, you take x squared term to the right side and then take the 9 to the right side. So you will get y squared is equal to 9 by 4 and something. And finally you get y is equal to simplify it, okay? Y is equal to 3 by 2 square root of 4 minus x squared, square root of 4 minus x squared. Therefore, the required area is, therefore, required area is equal to integral, the limit is from 0 to 2 and it is y dx. So what is y? Integral 0 to 2. Y is 3 by 2, 3 by 2 you can keep outside. 3 by 2 square root of 4 minus x squared. So it is same as the formula we used in the last problem. So it is 3 by 2 into, what's the formula we learned? X by 2 square root of 4 minus x squared, the same thing comes, plus a by 2, so it is 4 by 2 sine inverse x by, and then the limit varies from 0 to 2. Substitute the limit now, it is 3 by 2 upper limit. Here, when you substitute the upper limit, it is 2, right? So when you substitute 2 here, it is 4 minus 4, it is 0, x by 2 into 0, it is 0, so the first term is 0 in the upper limit. So the upper limit you substitute in the second term, it is 4 by 2 is 2 plus 2 into sine inverse 2 by 2, it is 1. Now minus the lower limit. Substitute the lower limit. Lower limit is 0. Substitute 0 in place of x. 0 by 0, 2 is 0. 0 into this is 0. So the first term is 0. And plus substitute 0 here. 4 by 2 is 2. And sine inverse 0 by 2 is sine inverse 0, which is 0. Sine inverse, but 2 into 0 is 0. Okay. So the answer is 3 by 2 into 2 times sine inverse 1, which is sine inverse 1 is 90. So it is 5 by 2, and that is equal to 2 and 2 gets cancelled. You get 6 pi. So area of this shaded region in the first quadrant distance, but we want for four quadrants. Okay, so area bounded by the four parts, so it is 4 times, and you can start it from the beginning itself. It's not needed to do it in the last, or at last you have to multiply it. So first it is equal to 4 times this 2 and 2 gets cancelled, so it is 6. So that is equal to 6 times. So it is 2 and 2 cancels, you get 6 pi. 6 pi square units. That's all. Now let's move to the next question, which is question number 6. Okay, let me read the sixth question. Find the the sixth question is find the area of the region in the first quadrant enclosed by x-axis, line x is equal to root 3y, and the circle x square plus y square equal to 4. So you have to consider x-axis, the line this, and the circle this. Now the line x is equal to root 3. First, you draw the circle of radius 2. Here, it is of the form x square plus y square is equal to r square, where r is the radius. So r square is 4, so r is 2. And so the radius of the circle is 2. So you draw a circle of radius 2. Okay. Draw a circle of radius 2. And now look at the question. It is bounded by the x-axis, the circle, and the line x equal to root 3y, right? When y is 0, x is 0. When y is 0, x is 0, right? And when y is 1, x is root 3 into 1, that is root 3. When y is 1, it is root 3 into y, it is root 3. Okay? And when x and y is minus 1, x is minus root 3. So you plot this line, you will get this straight line. Okay, this is the line y x is equal to square root of 3 into y. And now you just read the question now. It is the region in the first quadrant enclosed by x-axis, this line, and the circle. So x-axis, the line, and the circle in the first quadrant alone. X-axis, the line, and the circle in the first quadrant. So which is the area required region here? It is this. It is this region. Okay, it is this region. And now the thing is, you have the equation of the circle as x square plus x square plus y square is equal to 4. And the equation of the line is this. This line alone, when you're taking, you can, if you're taking the line, the limit varies from 0 to somewhere here. Up to this only you have the line. So you draw a perpendicular from that. You draw a perpendicular from this point to find the limits of the line. Okay. So this is where you get the limit of the line. And now you check out. So what will be that point? X is equal to root 3y, right? From that you have to find the x value. And now you check out. Okay, okay, what is this point? You want to find the limit of this, right? So you can, if you find the point, this is the point of intersection of the line and the circle. Point of intersection of the line and the circle can be found by solving the equation of the line and the circle. So equation, the given equations of the or equation of the line is x is equal to root 3y, and that of the circle is this. So if you want to find the point of intersection of the line and the circle, here you can solve it. Okay, so let us solve it. So from equation 1, what do you get? Equation 1, you get y is equal to y is equal to x by root 3, right? So substitute in equation 2. So equation 2 becomes x square plus x by root 3 the whole square is equal to 4. So it is x square plus x square by 3 is equal to 4, which is 3x square plus x square by 3 is equal to 4. So it is 4x square by 3. Okay, you can take the 3 that side. 4x square is equal to 12, and so x is equal to plus or minus 3. 4 into 3. 4 and 4 get cancelled. X square equal to 3, so x is equal to plus or minus square root of 3. So you're getting this point to be plus or minus root 3, right? So it is root 3. Okay, it's in the positive x-axis, so it is root 3. So you get this point to be y comma y comma x comma y. So it is root 3 comma y value. Y value is 1, right? Root 3 by root 3, it is 1. So root 3 comma 1 is the point. So what you get is this point is root 3. So you can take the limit as 0 to 3 for the line. Okay, the line comes up to 3. And from root 3 only the curve starts. From root 3 only the curve starts. That is the circle. So when you are taking the equation of the circle, the limit is from root 3 to 2. Only from root 3 to 2 you have the circle. From 0 to root 3 you have the equation of the line. So here when you are finding the area, you have to split it in this two. Like from 0 to root 3, you will be taking the equation of the line into dx. Okay, y into dx, that is from the line. Okay, and plus from root 3 to 2, it is the circle. So you will take y from the circle, okay, from the circle, and it is dx. So first let us find y from, okay, y from line is this one. Y is equal to x by 3. And what is y from the circle? We'll find it. So the limit there is from x is equal to 0 to root 3, and then from root 3 to 2. From 0 to 2, it is the line that bounds, and from root 3 to 2, it is the circle that bounds the region. So let us split the area. First, let us find the y value from this one. Okay. So what you get is y square is equal to 4 minus x square. So y is equal to square root of 4 minus x. Now all you have to do is find the area. Okay, area A is equal to this. So let us apply this one now. Let us work on this one. So required area A is equal to required area A is equal to area OAC plus area ACB. ACB OAC OAC and the next one is A, C, and D. Okay, A, C, and D. This is point C. Okay, now let's move on with. So that is equal to, as we said, the limit varies from 0 to root 3 when the region is bounded by the straight line. So you get y to y dx, right? You can write that first. Integral 0 to root 3 integral 0 to root 3 y dx. That y is from line, okay? That y is from the line and plus integral root 3 to to y dx. But this y is from circle. So what you get is integral 0 to root 3. It is what is y? What is y? X by root 3. That is x by root 3. And now other y is root 4 minus x plus root 3 to 2 root square root of 4 minus x squared into dx. Now you have the formula for the second integral, right? The first integral you can directly integrate it. X integration of x is x squared by 2. Keep the constant outside earlier, root 1 by 3. The limit is from 0 to root 3, 0 to root 3 plus what's the integration of this? The formula, direct application of the formula. That is x by 2 into square root of 4 minus x squared plus 4 by 2 into sine inverse of x by 2. And the limit varies from root 3 to 2. That is equal to 1 by root 3 into, you substitute root 3 the whole square is 3, so it is 3 by 2, and when you substitute 0, it is 0, so minus 0, 3 by 2 minus 0 is 3 by 2, plus, now you are substituting the upper limit first, so when upper limit is 2, when you substitute a 2 here, 4 minus 4 is 0, x by 2 by 2, whatever, 1 into 0 is 0, so the first term becomes 0. Second term, we put 2, it becomes sine inverse 2 by 2, that is sine inverse 1. So it is 4 by 2 is 2, sine inverse 2 by 2 is 1. This is upper limit minus. Now let's substitute the lower limit. Lower limit is root 3, right? So it is x by 2 means it is root 3 by 2. Substitute root 3 in place of x. Now 4 minus replace x by root 3 plus 2 into 4 by 2 is 2, right? 2 into sine inverse root 3 by 2. Sine inverse root 3 by 2. Now you just simplify it. 3 by root 3 by root 3 is root 3 into root 3 by root 3. So it is root 3 by 2 plus coming to this what first term is 0, you can leave it. Second term is 2 into sine inverse 1 is 5 by 2. Sine 90 is 1 minus and coming to this we didn't substitute the value of x here. So it is root 3, right? Root 3 the whole square is 3. Root 3 the whole square is 3. You can write one more step here by direct substitution, no problem with that. Okay, I have directly substituted Okay, minus root 3 by 2 into root 4 minus 3 is 1. Root 1 is 1, so it is stop there. Then plus, then what is root 3 by 2? It is minus pi by 3. And it is pi by 3. So what is pi by 3 now? 2 into pi by 3. And now the final step is root 3 by 2 plus 2 and 2 gets cancelled, which is pi. We take the minus inside, so it is root 3 by 2 minus 2 pi by 3. And now root 3 by 2 and root 3 by 2 gets cancelled. What is pi minus 2 pi by 3? It is 3 pi minus 2 pi by 3. It is pi by 3 square units. Okay. Okay, that's all. Now let's move to question number 7. Find the area of the smaller part of the circle. Circle x square plus y square equal to a square. Cut off by the line x equal to a by root. The next question is find the area of the smaller part of the circle x square plus y square equal to a square cut off by the line x equal to a by 2. So the circle is x square plus y square equal to a square, right? X square plus y square equal to a square is a circle of radius a. So you draw a circle of radius a. Now you see cut off by the line x equal to a by root 2. A divided by root 2 will be smaller than a. So a is here. So it is a point less than a, which is a by root 2. And the line a by root 2 you draw here. So this is the line x is equal to a by root 2. Okay, so this is the point a by root 2, this is the point A, and this is the point O. So you read the question, find the area of the smaller part of the circle, area of the smaller part of the circle, x square plus y square equal to a square, cut off by the line x equal to a by 2. So, x equal to a by 2 cuts off the circle into 2, right? Like this is left half, the bigger one, and the smaller part of the circle, this cut off by the line, this is this. The parts cut off by the line x equal to a by 2 is into 2, but we want to find that of the smaller part. That is, you have to find the area of, you have to find the area of the smaller parts. Okay, this is the smaller part cut off by the line. The circle is divided into two parts, and this is the smaller part. So this is the area you have to find. And okay, no, so, earlier we learned like region between the line and the y-axis and the circle. So we got this area, right? And this is entirely different. The circle is cut off by this line, and you have to find the area of the smaller part. So what next? You have to find the limits. This is x, x, and this is x dash, this is y, and this is y dash. So now limit is like a by 2, a by root 2 to a. Okay, a by root 2 to a. This is the region. And the equation you can get it from the circle. Okay, from the circle. So let us move on with that. The limit is from x is equal to a by 2 to x is equal to a. So now you find y from the given equation. The given equation is equation of the circle. From the equation of the circle, you find y. So y square is a square minus x square. So y is square root of a square minus x square. Now let's move with the formula and substitution. Okay, now find the area. Okay, now we want to find the required area, right? So area is two times because 0 a by 2 to a. The first part you can cover it with this, and for the second part you can just take 2 and in 2 times of that because the same area comes here. So now 2 times y into dx, the limit is a by root 2 to a. And y is a square minus x square substituted. Now the formula, you have the formula x by 2 into square root of a square minus x square plus a square by 2 into sine inverse x by a. Substitute the formula, that is equal to, first apply the upper limit. When you apply the upper limit, when you substitute a, this term becomes 0. So 0, first term you can leave it. So when you substitute a, it is sine inverse of a by a, it's sine inverse 1. Sine inverse 1 is pi by 2. So a square by 2 into pi by 2. So a square by 2 into pi by 2 minus, then substitute a lower limit, a by root 2. A by root 2 in the first term and a by root 2 in the second term. Now you simplify it all and then simplify and you'll get the final answer as a square by 2 into pi by 2 minus 1 square root x. Now let's move to the next question, which is question number 8. So the eighth question is, the area between x is equal to y square and x is equal to 4 is divided into two equal parts by the line x equal to a. So it is given area between these two lines. The curve x is equal to y square. The curve x equal to y square and the line x equal to 4. Okay, the area between these two is divided into two equal parts by the line x equal to a. So actually, what is x is equal to y square? Y square is equal to x is of the form what? Y square is equal to x is of the form y square is equal to 4ax, right? So it is symmetric about x-axis and open right. It is a parabola symmetric to the x-axis and open right. If you have minus 4ax this form, then it is open left, right? So here it is just of the first form. X y square is equal to 4ax form. It is a parabola that is open right. So you draw the parabola that is open right. And you can, it is actually got by plotting the points, but you can draw a rough diagram. Okay, draw it and then x equal to 4 you draw now. X is equal to 4. Draw that. So draw x is equal to 4 and curve that, okay. And after this, what you are supposed to do is, now it is given the area between this curve, that is the parabola, and the line x equal to 4, that is total area, that is dotted and striped. Okay, the total area is divided into 2 by x equal to a. Draw the line x equal to a. It is said that it is given that this line x equal to a divides the area between the parabola and the x is equal to 4 line into two equal parts. Upon this area is equal to this area. The stripe is equal to dotted. Okay. So all you have to do is find the area of the two and equate it so that you can find A. Find the area of the dotted region, find the area of the striped region, and then equate it, and then you get A. You get A. Okay. So here look into the limit in the dotted region. It is from 0 to A, right? And mm, 0 to A. And in the stripe, it is from A to 4. So the limit there is from x equal to 0 to x equal to A and x equal to A to x equal to 4. From 0 to A, it is the curve, it is a region under the curve which is equal to y square. And so you can take y from the parabola, okay? And now the in the striped region, it is the area under the curve under the curve parabola, right? Under the curve. So it is also the curve equal from the curve x equal to y square. So the same y is called both areas. Okay. So now the given curves are one all these lines x equal to y square, x equal to 4, x equal to a. And now it is given x equal to a divided by area into two equal parts. Therefore, the area of this region dotted will be equal to area of the stripe. So you get area of the dotted is from 0 to a, and area of the stripe is from a to 4. Limit x equal to a to x equal to 4, and you can take it two times. Okay, so you are getting the upper half. So another half, to get the another half, you multiply it by 2. And now here the 2 and 2 gets cancelled. 2 and 2 get cancelled out. And what else? Mm, okay, 2 and 2 gets cancelled, and so you're getting this. Now, why you're getting as square root of 2? Substitute that square root of x from integral a to 0, square root of x and square root of x. What's the integration of square root of x? It is x power 1 by 2, right? So integration is x power 1 by 2 plus 1 by 1 by 2 plus 1 is x power 3 by 2 by 3 by 2, x power 3 by 2 by 3 by 2 on both sides. So the limit varies. So 3 by 2, when it comes to the top, it becomes reciprocal. 2 by 3 into x power 3 by 2, and what? In the right side also, it is 2 by 3 into x power 3 by 2, x power 3 by 2, and the limits. And write the limits very carefully. And now this 2 by 3 and 2 by 3 cancelled, you get it the substitute the limit. Upper limit minus lower limit. So upper limit is a, lower limit is 0, so its second term goes off, and here upper limit is 4. So 4 power 3 by 2, lower limit is a, therefore minus a power 3 by 2. And now bring this a power 3 by 2 to the left side, it becomes plus a power 3 by 2. So you get 2 times a power 3 by 2 is equal to 4 power 3 by 2. Okay, 4 power 3 by 2 is 8. So 2 in that is equal to 8, and 2 take it to the right side. 8 by 4 is 2. And now rising to the power 2 by 3. So if you're multiplying it by 2 by 3, 3 and 3 gets cancelled, 2 and 2 gets cancelled, you can find a, right? So rising to the power what 2 by 3 on both sides, you get a power, this is a equal to 4 power 2 by 3. So in the value of a is 4 power 3 by 2. Okay, let's move to the next question. Okay, the next question is choose the correct answer. This is question number 12. Area lying in the first quadrant and bounded by the circle this and lines this, and the lines x equal to 0 and x equal to 2. X equal to 0 means it is y axis, right? X is equal to 0 is the y axis. And x equal to 0 and y is x is equal to 2 is dash. So you have to find the region bounded by this x equal to 2, there's x equal to 0, and the circle this. Actually, it's in the first quadrant, right? First quadrant alone. So here the region you have to find the area of the region, how to find this shaded region. So if you want to find the area of that, know the limit. Actually, how did you draw the circle? It is of radius 2. Here r square is equal to 4, so r is equal to 2. R square is 4, so r is equal. The radius, circle of radius 2, and the line is x is equal to 2. So both will all in the same point. X equal to 2, and the radius of the circle is 2. So this, okay. And x equal to 0, x equal to, and the circle of radius 2. So this is the area we have to find. So the limit varies from 0 to 2. So integral 0 to 2 y dx. Y you get it from the equation of the circle. What's the equation of the circle? X square plus y square equal to 4, and you will get y is equal to square root of 4 minus x. 4 minus x. So direct formula substitution. So integral of that is equal to this. Substitute the formula, and substitute the formula, and then substitute the apply the limits. So upper limit minus lower limit. When you apply the upper limits, first term becomes 0, that is x square, right? So it is 4 minus 4, it is 0. So coming to the second, it is 2, 4 by 2 is 2. And sine inverse 2 by 2 is 1. Sine inverse 1 is sine 1, 2 into sine 1. When it is 0, no, you put 0 first time goes up. Sine 0, 0, second time goes up. So it is only this much. 2 into 5 by 2 is 5 square units. Now let's move to the next question. It is question number 13. So the next question is area of the region bounded by the curve y square is equal to 4x, y-axis, and the line y equal to 3. So it is a parabola. The parabola is of the form y square is equal to 4ax, right? So it is open right. Oh, it is symmetric about x-axis and open right. So the parabola I have to draw this way. Symmetric about x-axis and open right. So you have to draw the parabola that is open right and symmetric about x-axis. Now it is the we want the region that is bounded by parabola and y-axis. So this is the parabola and this is the y-axis and the line y equal to 3. So you have to consider this line y equal to 3. So this is the region. So region between parabola, y-axis, and the line equal to 3. So limit varies from 0 to 3, right? 0 to 3. So you have to take the limit of 0 to 3 and the x dy. So you have to take the limit varies from x is equal to y is equal to 0 to y is equal to 3. It's along y axis. So the limit is taken in y side. So you have to find x. So y square is equal to 4x implies yx is equal to y square by 4. So substitute in place of x, y square by 4, integrate it, substitute the limit, you get the answer. That's all. So this is the last problem and we will end this. So all you have to do is revise all the problems, um, listen to the video, understand it, and then take down the question and do it by yourself and practice it. Practice some extra questions as well. Thank you so much. So the next class we are going to start the next chapter. Thank you so much.